Okay. So today it's a small lab. We just continue above what we taken last time in our last lab 2. Okay. So basically we have a small introduction about hexadecimal numbers. Maybe some of you don't know what hexadecimal representation means, so I should, give some introduction about it. So basically, any number representation needs some what's called the basis. So for example, for the decimal numbers that we all know, okay, our basis is 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 10 digits, and from these 10 digits, from 0 to 9, we can construct a number. In binary, for example, the thing that we usually do, we have only two digits, 0 and 1. And from these two digits, so it's called binary, we represent any number. In hexadecimal now, we have 16 digits, okay? From 0 to 9. Let me have the... from 0 to 9, and A, which represents 10, B, 11, 12, 13, 14, 15. Okay, and from these 16 symbols, we're gonna construct or represent any number. Okay. Okay, so for example, let's do the conversion. How, for example, to read, a hexadecimal number, something like this, 1A7. So we have here 3-digit number, hexadecimal number. Okay, and this means hexadecimal. And in programming, we usually do 0x. So whenever you see a number with 0x in the front, this means a hexadecimal number as well. So let's see how to convert this into decimal. So 1 is the third digit, 8 is the second digit, and 7 is the first digit. So we take the 7 and multiply it with 16 to the power 0. A would be multiplied to 16 to the power 1. And the 1 will be multiplied to 16 to the power 2. Then you add all these together, you get a number. This number will be decimal number. Okay, so this number here, 423, can be written as such form in decimal or such form in hexadecimal. Okay, this number in here, whenever I say 13, but with hexadecimal representation, so this is not our 13 that we usually do. Okay, I'm sorry. Yeah. Okay, so how is this like? So this should be 1 multiplied to 16 to the power 1 plus 3 multiplied by 16 to the power 0. So 16 plus 3 is actually 19. Okay, so we can write 19 in that way or in that way, whatever you like. Okay, and you can even write D, just D here. Okay, so D is also 13. But to make it less complex, we just represent it with only one letter instead of two letters or 2 digits. Okay, any question on that? Any question? No, good. You guys know the hexadecimal, right? Because we're gonna use, yeah, good. We're gonna use it all over the course from now on. Why we need hexadecimal? Because in many cases we will deal with registers, usually 32-bit registers. Okay, and you have 32-bit in binary, so it's really difficult to convert this number into and visualize it using decimal. Okay, and we need the binary form to make it more visualizable to our minds. Another representation that will be also easy for you to visualize is to represent this 32-bit into hexadecimal representation, which will be only 4 digits. Okay, so whenever you want to convert a binary number into a hexadecimal number, or its hexadecimal representation, I mean, what you're gonna do is that you divide the number into chunks. Each chunk has a 4-bit. Okay, so this guy, for example, very big number, and if you wanna convert it to binary, I'm sorry, to decimal, it will take a lot of time, a lot of multiplications. And if you look at the decimal number, you cannot visualize what each bit in the original binary number is 0 or 1. So what we're gonna do here, as I said, we divide it in 2 chunks. So, and each chunk has a 4-bit. So we have here 4-bit, and do this from right to left. So 4 bits, another 4 bits, then last 4 bits. Okay. If the number is not consistent of multiple of 4's number of digits, okay, then you know just add zeros at the end at the end chunk here. Okay. So you take each 4 bits and convert it to its hexadecimal representation. So this guy, for example, is just 1. This guy is 10, and 10 is hexadecimal, is A, so you put A here. Then this is 7, so you put 7. So this is representing, this is, this is as a binary, as a non-binary number, is equal to this number 1A7 is in hexadecimal. Okay, and now instead of looking at this 12 bits, you can look at the 3 digits here. For example, if you want to know what is bit 0 looks like, if is it 0 or 1, just look at the last digit here, which is 7. Okay, and you know it's very simple. You can visualize that 7 is 1110, so you know now bit 0 is 1. Okay, if you want to know if bit 5 is 1 or 0, look at this guy here, the second digit, and you know A is 10, 1001. So you know now that bit 5 is 1. Okay, so it's a good representation for long binary numbers, and still you can visualize what each bit represents, 0 or 1. Okay, and here is more examples. Here is a binary form of some number. This should be 5 in decimal, and of course hexadecimal will be the same, also 5. This should be 17 in decimal, and in hexadecimal you take the first 4 bits, which is 1. Then you just add zeros for the second chunk here, so it will be 1 0 0 0. So it's still 1, so it's like 11. This would be 0 40, because the first 4 zeros are 0, and then we have 0 0 1. You add 0 here, so it's still 4. And this would be, you know, of course, if you look at this number here, you cannot imagine what each bit represent in this 32-bit number. I'm sorry, 16 or 32, I don't know. This is 16-bit number. Okay, but just look at the hexadecimal, just 4 digits, and you can visualize what each bit here value is, the value of each bit here, 0 or 1. Okay, this is good.
Professor, I have a question.
Yes.
For the third 4 bit, you said it's 10. How is it 10?
What?
On an example, in the example one, where it says example.
This one, right?
That one.
Yeah. This is This, if you convert. That 9? Oh, I'm sorry. Yeah, you are right. You are right. So okay. So let me. Okay, I'm very sorry for this. You are right. Thank you. Yeah, this is 9. So to make it 10 and 1. It's okay now, right? Yeah. If we look at here, yes. Good. Thank you very much. Thank you very much.
No problem.
Okay. The basic, core for our lesson today is with bitwise operations. So in our last program, let's look at it. So in this program here, okay, in which we program some lead in the launchpad, we needed to set up some registers regarding, port one, in order to set, send 0 or 1 to the lead one in the launchpad. Okay, and we were doing that in a very crude way. We were, we want to just exchange only 1 bit in 8-bit register. Also, we were changing all the bits of that register. So for example, in here, the direction register, B1 direction register, we want to set the bit 0, okay, as 1 to make it output. Okay, so also using this line of code here, all the bits of direction register will be changed. So yes, bit 0 will be output, but all other bits will be 0. So you are setting them as inputs, although you don't need this. Okay, and this may corrupt some other stuff in your code. So maybe there was something before that line, maybe for a more complex program, there was a line before that, okay, in which you set one of the bits as input, then you forgot and you do that, then I'm sorry, as output, then you forgot and do that, so you reset this bits that you set it before as output as input. Okay, so we need to, pinpoint, we need to look at some particular bit or bits, okay, and they change them only based on our application, and keep other bits with their values, whatever they are. Okay, and this is called bitwise operations. So let's see what these bitwise will do. So we have 3 basic bitwise operations. And bitwise operation, or bitwise and bitwise or, and bitwise XOR. So this is bitwise and. So let's have the laser bin. This is laser bitwise and. This is bitwise or, and this is bitwise XOR. Okay. So basically, guys, what's or and. So here you have only 2 bits. Bitwise. Remember, bitwise means we are dealing with only 1 bit. Okay, and here is their and, their or, and their XOR. Okay, and for the XOR, because it's really, sometimes it makes some confusion, you just count the number of ones. If they are even, then the output is 0. If they are odd, the output is 1. So here, for these 2 lines here, these are odd number of ones, so we have 1 in the output. Here we have 0 ones, which you consider the even for some reason, I don't know why. So we have 0, and here is you have 2 ones, so it's even number, so again the output is 0. Okay, so let's see how we do bitwise operations. Okay, so for example, let's assume we want to make a bitwise OR. Okay, and this is usually needed when you turn on some lid. Okay, you want to send 1 to this lid, okay, to 1 bin, and this bin is connected to the lid, then the lid will turn on. Okay, for example, B10, the bit that we used last time in our last lab, this bin, we know that it's connected to the lid 1 in the launchpad. So if we set its function as a GPIO and set it as output and send 1 to this bit, set it to 1, then we will turn on the lid 1. Okay, but we want to do that without affecting other bits. So previously in our last program here, for example, here we are setting bit 1 as 0. At the same time, all other bits are also 0. Okay, no, we want now to pinpoint at this bin only. Okay, or target this bin only, bit 0. So let's see how we're gonna do that. So we're gonna do that using this using bitwise OR. So whenever you want to set a bit, I mean make it 1, you use bitwise OR. So OR, bitwise OR usually come with setting. When you have a setting application, you want to set some bit to 1. So, and this is practically the line of code that you're gonna use. B1 out, you know, guys, the out register in B1 board is the register that takes the values for the output bins. Okay, so if you set bit 0 in that register to 1, this means B1 0 will be 1. Okay, so what you're gonna do exactly is as follows. You say that you write B1 out bitwise OR 0x01. 0x means hexadecimal. Okay, from now on we're gonna use hexadecimal because we can't put binary number in C++ in C code, in C programming in here. So that's the problem why we use hexadecimal. Okay, and again, sometimes you have very big number, very big number, with high number of bits. So again, the hexadecimal representation will be easier for you. So let's analyze what's gonna happen exactly when we launch this code or when we run our code. So assume that bout1 register have some 8 bits, whatever they are, but you wanna, X means don't care, I mean 0 or 1. But yeah, you wanna bit 0 to be 1, to be set to 1. Okay, so I'm sorry, this is OR, this is not AND. So you're gonna bitwise it with this number. This number in hexadecimal, when we convert it to binary, it will be the following. This 0 will be 4 zeros on the left hand side, on the left hand chunk, we can say, and this one will be 0 0 0 1. Okay, then when you do the OR between bitwise OR between this 8 bits and those 8 bits, we will do it one by one. So or 0, I mean whatever in here, or 0 will give you the same thing. Okay, so 1 or 0 will give you 1, 0 or 0 will give you 0. So whenever you make or with a 0, you will get the same stuff. So here is the note for this. 1 or 0 is 1, no change. And 0 or 0 is also 0, again, no change. So generally, X or 0 is equal to X. So these 7 digits in here will be the same, whatever they are, 1 or 0s. But let's see now for bit 0 here, it's the last digit. X or 1. X, whatever, if X was 1, for example, so 1 or 1 will be 1, good. If X is 0, 0 or 1 is also 1. And this is our, this is the required. So we wanted in the first place bit 0 to be 1, so that we use the bitwise OR. So we could succeed in setting bit 0 to 1 as we want. At the same time, we didn't change other bits in B1 out register. Okay, this is clear, guys?
Professor?
Yes.
So if you just use the decimal value, does that affect other bits? So let's say if I put, because that's how I did it on my lab. I just put it as the decimal value. It seemed to work, but is that not efficient?
Yeah,
or does that?
It should. Yeah, no, it should work. It should work.
Okay.
It should work. Yeah, but usually we use the hex representation to make it easier to visualize what each bit is exactly is. Okay, so when you debug your code, you can visualize even certain bits in the numbers that you are dealing with.
Okay, it's just it was just easier to use decimal in the lab because it was just 1 to 7. But
yeah, that's right. Yes. But later we're gonna see more complex, sophisticated examples when you have, for example, want to set bit here, so it will be harder at that time to to get the decimal or to deal with the decimal number. Also, it's right. Okay.
Got it. Thank you.
Okay, so this is bitwise OR. Now the bitwise and we use bitwise AND to clear bits. Okay, so clear bits mean set it to zero or reset it. Okay, so one example again is to turn off a lid. Okay, and we did this, you know. So again, when you turn off the lid is connected to some pin in the microcontroller, and you wanna put zero to this pin so that the lid will turn off. Okay. Now we wanna do the opposite now. Okay. Uh, uh, Clearing bit. So what you're gonna do exactly again is that line of code here. Okay. So for that example, that we wanna clear bit zero in port one, or B10, port 1, bin 0. Okay, so now we want a bitwise with another value, not 0, 1 like the bit that like the bitwise OR. It will be FE. And let's see, analyze exactly what's gonna happen with this. So this is B1 out register. X means whatever the value are there, zeros or 1. Okay, and zeros, and here is FE. FE is F is 1111 and the E is 14, which is 1110. Okay. And now when you bitwise AND, you're gonna AND bit by bit. So X and 1. If X is 1, 1 and 1 will be 1. If X is 0, 0 and 1 will also be 0. So you will not change the value, and that's the requirement. And here is you know, the rule for it. So 1 and 1 is 1, 0 and 1 is 0. So whenever you ending with 1, there will be no change. Okay, the 1 will still be 1, the 0 will be still 0. So X and 1 is X. So X and 1 is X, X and 1 is X again until the 7th here. So all these 7 bits will not be changed. But now let's see what's going to happen to the last bit, bit 0. X and 0 will be 0. Because if X is 1, 1 and 0 is 0. And if X is 0, 0 and 0 still 0. Okay? And that was our requirement, to reset or clear bit 0 in B1 out register, so that we can turn off the lid, for example. Okay. Also, there is an easier, you know, way to do it. Maybe it's, you know, how can I say this? You can do it in that way. Okay, that way is also, you know, famous, and if you search on the internet, you will see many, you know, stuff like this. And instead of dealing with FE, you can do it with the negate or the complement of 0, 1. So again, what's the bin that you're gonna reset or clear is bit 0, right? And if you see in the our example here, we use 0, 1 for bit 0. So here we are also using 0, 1, but the negate, the complement of that number. So let's see what is this equivalent. It should be, of course, equivalent to FE. So let's see. So complement of 0, 1. In binary, this 0 will be 4 zeros, and this one will be 3 zeros and 1. And the complement of that number here, you should complement each bit. So it will be 1, 1, 1, 1, 1, 1, 1, 0. Okay, which is FE, just like this. So you can write this line of code or this line of code, and both will be the same. Both will lead to the clearing of bit 0 in B1 out register. So you can, you know, turn off the lid. Okay, guys, this is clear?
Yeah.
Okay. Genesis, you have a question? Genesis.
Can you hear me now, Professor?
Yes.
Okay, sorry, my mic was messing up. But
Okay.
just to simplify it, basically, when we do the AND, it basically just zeroes out the first bit, and then when we do OR, it just it sets the first bit. with this
Yeah.
whole bitwise thing? Okay, it's just a different
Yes.
method. Okay.
Yeah. So whenever you wanna clear, use bitwise AND. Whenever you wanna set, I mean make it one, use OR.
Okay,
Okay.
and from now on, we're going to be using bitwise and
Yes.
hexadecimal
Yeah.
values.
Yeah.
Okay, got you.
Yes. Okay. Last stuff here is XOR network. I'm very sorry for this. I'm gonna update the file that I sent you. Anyway, so the last operation is bitwise XOR. Okay. So now we're gonna combine both together. So if you wanna blink the lid, okay, make it for example for some time on, for some time off. Then you wanna toggle the output. Toggle mean switch on and switch on and off, something like this, or switch between two values. This is the toggling. So we wanna send one for some time, then set zero for some time. So this is actually switching back and forth between two values, and this is toggling. And you can do that simply using XOR. Of course, as I mentioned last lab, you can do it in two steps. First send one, then wait for some time, then send zero, and then loop again and stuff. But you can do that in one step using XOR. Okay. So let's see the rule here. 1 XOR 0 is 1. Why? Because the number of ones is odd, so the output is 1. And the output looks like equal to the input. And 0 XOR 0 is equal to 0. So we have no change. Whenever you make an XOR with 0, you have no change in the input. The input will be the output. Okay? So generally, X XOR 0 is equal to X. Okay, so we're gonna use zeros now to do that, to not change some stuff. And the bit that we wanna change its value or toggle its value, we're gonna use 1 for it. Okay, so, and here is the line of code that do this. B1 out, X bitwise XOR 0x01. Okay, so this will, toggle bit 0 in B1 out register. So if this is B out register, for example, when we make the XOR with 0, 1, 0, 1 is 0, 0, 0, 0, and 1 is 0, 0, 1, 0, 0, 0, 1. Okay, and when you do the XOR in a bitwise fashion, so X XOR 0 is equal to X. Whatever in here will be here. Whatever the input will be the same here. If it's 1, it will be 1. If it's 0, it will be 0. And the same for other X's here. So these 7 bits will not be changed. They will keep its previous values. But then whatever in here will be complemented in here. So if we have a 1 here, 1 XOR 1 is 0 because the number of ones is even. So we could change 1 to 0. And if there is a 0 here, then 0 XOR 1 will be 1. So we also change it the 0 to 1. Okay, so you can blink the lid or switch or toggle this bin 1.0 based on bitwise XOR operation. Okay, and here is the lid one, the same program that we used. I even put the same same previous lines of codes in which we will just in a very crude way set bit 0 and the rest of bits as well, but I did it in a bitwise fashion. Okay, so let's see here what each line is meant to be, or what each line is meaning exactly. So here again, the same scenario. We have the same scenario. We want to control lid 1 on the launchpad from the schematic in the launchpad user guide. We know that lid 1 is connected to B1.0 or port 1 bin 0 in the microcontroller. So we want to first set the direction of this bit to output. And this happens by setting the first bit 0 in B1 direction register to 1. So if we want to do that without affecting other registers, and we want to set it to 1, so we were going to use bitwise OR. We use bitwise OR when we set something to 1. So here is a line of code that we used before, B1 direction equal to 1. This will set the first bit to 1, so it will be output, and the other bits will be set to 0, so they will be input, even though they may be used other way in the code as output as well. Okay, so we're gonna use the bitwise operation with 0 1 here, so that only bit 0 will be set to 1, and all other bits in direction register of port 1 will not be changed. Okay, then as we said, each bin may have 4 functions. Okay, and the GPIO function is the first function of them, and to set the function as a GPIO input output bit, you set the selection register registers 0 and 1 to 0, and hence if you want to set bit 0 as a GPIO, then we should set clear bit 0 in cell 0 register and the clear bit 0 in cell 1 register, and we do that by bitwise AND. So if you do that line of code, for example, bit 0 will be 0 in selection register 0, and all other bits will not be affected. Okay, again the same for cell 1, selection register 1. Here is some initial value. You can just ignore this line of code, that's fine. But here we just send 1 to the lid, but this is just initial value. You can send 0, whatever you want. Okay, it's just initialization. So here we want to send 1 to the bin 0 without affecting other bits. Since we want to set, then we use bitwise OR. Okay, and with that hexadecimal value 0 1, only bit 0 of the output register of port 1 will be set to 1, and all other bits will not be affected. Okay, then we do the same loop that we see last time. Okay, and here is a toggling. So we are toggling here with bitwise XOR with 0 1, so only bit 1 will be changed or switch on and off, or switch between two values or toggling. Okay guys, this is clear?
Mr. Mustafa,
Yes,
I'm
Johnny.
confused on like lines 13 and 14, how they exactly work. I mean, it's
13 and 4, yeah. Okay.
yeah, because I still didn't understand it from like the previous lab. Because what I'm thinking is that it sets it as a GPIO or primary or secondary, right?
Sure.
Based on
Yeah.
the table.
Yes.
But is this changing like a pin to be like a
No,
GPIO
this
or
is not a bin.
primary? Or...
No. This is not a bin. Okay. We are talking about a bin. Okay. So we are configuring a function of some bin 1.0 as an output. Okay. To do that, there are 2 steps. The first step is to set the direction as output, and we do that from here. Okay.
Right.
The second step, and both are, you must do both. The second step is you must tell the processor or the microcontroller here that this bin will serve as a GPIO.
Right.
Okay, and so that it can be used as input and output. So it may be more logic, although it doesn't matter in the programming or coding, to put these 2 lines of code before this one. Okay, so yeah, let's explain it in that way. The 2 steps are as follows. First, you should tell the microcontroller that bin 1 should serve as a GPIO. Okay, so you tell the microcontroller this information by configuring 2 registers. Okay, inside the microcontroller. The first register is called B1 cell 0 and B1 cell 1. So there are in each port, there are two registers called the selection registers. Okay, cell 0 and the cell 1. So if you want to tell the microcontroller that I am gonna set pin 0 as a GPIO, you should put 0 in bit 0 of selection register 0 and put 0 again in selection register 1. Okay. After that, you're gonna tell the process. Now it's a GPIO. Now you wanna tell the processor or the microcontroller if it's input or output. Then you do this. You define the direction using this line of code. I will change it. In programming, it doesn't matter. Okay, but maybe it's more intuitive to put this before this one. Clear or still?
And what if, like, say you wanted to make like bit 6 as like an output or something like that? How would you change the P1 cell 0 exactly? Would you have to
Good,
do
good.
like 0 times 0.6 or something, or not 0.6?
No. Okay, now we are dealing with bit 0, right? So if you want to set bit 6, for example, then you point at pin 6. So the
Right.
6th bit in cell 0 will have 0, and the 6th bit of cell 1 will have 0. So of course you will change this value here.
Okay.
So let's do that on tablet. Just give me a second. I don't know. What?
Those lines of code are kind of like confusing for me.
No, that's fine. Let me share the tablet, and I hope the tablet is working because I tested it before and it looks like not working. But let's start. Let's see. You can see the tablet, right?
Yes.
Okay, it's not working. So let me try to figure out what is the problem exactly. I hope it works now. Good. You guys can still see my tablet or not?
No. Or now we can.
Okay. Okay, so let's do. Okay. So let's talk about board. This is just general discussion, and we go then to the board, pin 6 or whatever pin you want. So
I think like your
yes.
mic got muffled for some reason. I think it's, well, I don't know if it's good, but it just had gotten muffled for a bit.
I don't know. How about now?
It's good.
Okay. So here is the microcontroller. Okay. Let's assume here is port 1, for example, and here is pin 0. Okay. And let's talk about pin 2. I will not talk about pin. So we're gonna make some examples that we didn't see before. So let's assume there is a LED connected to pin 2. Okay, so to turn on this LED, you should put 1 here. To turn it off, you should put 0. Okay.
Right.
That's good. To do that in our microcontroller, you should do that in some steps. First, so the requirement is to toggle the LED. This is a requirement. Okay, the LED is connected to pin 2 of port 1. This is port 1, for example. Okay, or port 2. Let's assume it's port 3, another port. Okay, to make it completely different example. Port 3. Good. So what we need now, we need to tell the microcontroller that we need pin 2, port 3, in port 3 to be
Serve as
an
an
output
output.
pin.
Right.
What?
Yeah, to serve as an output pin.
Yes, yes. So to do that, we have two steps to do. First of all, setting B2, B3.2, port 3, pin 2 as GPIO. Okay. So you wanna to do that. There's some way to communicate this to the microcontroller, and we do that using the selection register. So there are two registers inside the, we cannot see inside the microcontroller, called cell 0 or cell 1 and cell 0. Okay, they have 8 bits. Okay, so to set pin 2 as a GPIO, we go to the manual, like the manual, and look at the these tables I showed you last time, and see what kind of values we need to set cell pin 2, pin 2, pin 2, yes, in port 3 as GPIO. You will find it 0, 0. Any GPIO function usually 0, 0. All the time 0, 0. Not usually even. Okay, so you need to put here, where is pin 2? Pin 0, 1, 2. Yeah, so we need to put here 0, and you need to put here again 0. Okay, so you do that like this: B1 cell 0 equal to, if you need to put 0, so you can just put 0 like this. Also, this will set all the bits to 0. But if you just don't care about the other bits and you are sure they are not connected to anything, or you don't need them, then you can do that. So this is another way to do that, and of course B1 cell 1 equal to 0. Okay, another way to do that, by bitwise operation, bitwise AND in specific. So B1 cell 0, then this means bitwise AND. And now let's figure out what is the value that I should put here on the right hand side. Okay, what you want exactly, you have 8 bits, you don't want to affect, these are the 8 bits. You only targeting this bit here. Okay. You're only targeting these bits, and we don't want to change all these bits. Okay, so it's assumed this is the previous value of cell 0. Oh. So let's assume this is cell 0. Okay, and you wanna clear this one to 0. Okay, so we should end with something that will only change this bit here to 0. We know that if we end with 1, this will not change anything. So you don't want to change this bit, so end it with 1. We don't want to change this bit, so end it with 1, 1, 1, 1, 1, 1. Now we want to clear this one. We want to make it 0. So end it with 0, because anything and 0 will be 0. Okay. So let's see the result of this. X, 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 0, X, X. So we only change it bit 2. The second bit, that's the third bit, bit 2. Okay. So you can do that in that way. Bitwise and this number as a hexadecimal is F, and this one here is this is 8 plus 2 plus 1. This is 11. C A B C D. This should be B. Yeah, B. It's 11. So you end it with F 0x FB. And again the same for B2. I'm sorry, B1 cell 0, cell 1.
And Professor, would it be possible to also do 0x04 for that? I mean not 0x.
Not, yes, this,
okay.
yeah, I will just, this was in my mind. That's right.
Okay, gotcha.
So a third solution for it is to do in that way, which is easier. So let's, again, this is cell 0. Okay. You only want to change this bit here. Okay. So you can do it in that way, and not, of course, I'm sorry, 0, 0, 0, 0, 0, 1, 0, 0. I mean, both one for the ones for the bit you want to change, and other should be zeros. This will give you smaller number, so it will be easier even to visualize, which is it's just 0, 4. That's the point of it. Okay, but still and. So of course, if we make note for all of this, it will give you 1, 1, 1, 1, 1, 0, 1, 1. The same as FE. Okay, so you can also do this way. Zero 4. I'm sorry, this is not B1. This should be B3. But we used it to deal with B1, so. Okay, so this is the first step. The second step, set the bin as output. The first solution for it, simply B1 direction. So there is, let's go back. Yeah, there is another, So these two registers in port 3 are used to know the primary, the function of the bin, either GPIO, primary, secondary, tertiary. Okay. Now, if it's a GPIO, the microcode still needs to know if it's input or output. So another register called direction register, DIR. Again, it's 8 bits. One, two, three, 4, 5, 6, 7. Again, it's 8 bits to determine the direction of a certain bit, either input or output. So we are interested here in this bit. This should have 1, which means output. So the second step, we can do B1 dir and just do 4. Remember, 4 in decimal means this number. Since this is 8-bit, this will be translated into this number in here. Of course, it's equal to 4. Whenever, because all the zeros on the left, doesn't count. Okay, but at the same time, now you are setting all these bits as input, and you want to avoid this. So we're gonna use the bitwise operation. B3 again. B3 dir. We want to set to 1, so we use bitwise OR. 0, 4. And let's do that. Assume this B1 dir has some value in the beginning. We want this to be 1. So we want to OR it with 0 everywhere, except here will be 1. So X or 0 will be X, 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 then 1. So you just change it a bit too. Okay, Johnny?
Could you go up a little bit? Okay, I think I get confused because I don't get how P3 cells 0 is equal to 0. How does it know to exactly look at bit 2 in both cells?
Your voice was cutting. Your mic, Johnny, is have a problem. Does anybody understand what he said? Guys, does anybody got anything?
I couldn't really hear him, but he said something about not understanding how. Oh, he typed it in chat.
Okay. I don't understand. Yeah, when you okay. No, when you do that, okay. So the compiler is intelligent. So he knows that this register is 8-bit. So he will convert this number into 8-bit as well. So this number here will be represented as this, like this. And all these 8 bits will be, pushed to cell 0 register. So what you want in that case is this bit to be 0, and it's now 0, but you also set it other bits to zeros. I hope this is the answer that I understood you correctly. Did I understand you correctly, or this was your question and this is the answer that you're looking for? Johnny. Good. Any other confusion you have, or anyone of you?
Professor, P3, are you using that just as an example for this case, or?
Yes, just an example, because we usually, I mean, by giving example on B3 that the procedure is the same, whatever the port is. We have 10 ports in our, or 10 ports, yes, 10 ports, okay? And each port is 8 bits. And whenever you're gonna use any of them, you must follow the same procedure.
Okay,
First,
gotcha.
First, determine the functions that you're gonna use, okay, because these bins can serve multiple functions. So the microcontroller must know which function you need. Then if it's GPIO, for example, then it might be input or output. So you must also define the direction input or output. Then you do whatever. Okay. Okay. So I hope I was clear enough. So let's go now to Code Composer Studio and do our stuff. Let me show you mine. So this is my program. Okay. And
We can't see it, Professor.
Okay. So this is my program in here. And you can see it now, right?
Yes,
right.
you can.
Okay. So let me combine it. Yeah, good. It's the same stuff. Yeah, I'm not doing in something. But here the delay is much bigger, so it will take time to let us reduce it a little bit. Okay, then we hit run. Yeah, so here is the program, guys. Here is the red is blinking. Okay. But before you go to your laptops and stuff, just want to show you something. So yeah, this is called the workspace, this thing here. By the way, this is the workspace. And if you look at your computer, you will find all these projects, any project in this workspace. So we have here 4 projects. So you will find the folder, which is your workspace, and contains 4 folders. Each folder with a name, just for example, you will find the folder called A1 test, another folder called A2 GPIO lead 1, and so on. Okay. If you have one of them is running, then a good trick to avoid all this driver lib and setting, you can do copy and paste. So for example, let's copy and paste. Yeah, this is what we will do today. So this is the program that we saw last time. Okay, and you will just make some changes. So if you go back here, it is exactly the same code, but you will replace this line here by this line, these 2 lines by these 2 lines. So it's the same code, right? So don't need to make it from the beginning. So what you will do is and to make it easy for you, if this is working correctly, just right click and copy, and then come here in any space and just make paste. Call it for example, what? So it should be called okay. Copy. I don't know. Oh yeah, then paste. For some reason it changed it to 2. Why? I'm not sure why. Anyway, test. Oh yeah, he changed the name because he can't create another project with the same name. So he changed the name from 1 to 2. Okay. So let's call it lead 1 test. Okay. Copy. Yeah. So he created the same. So if you look at the folder now, you will find 2 folders. This one is, I'm sorry, 5 folders, because this guy is newly created. It's a workable a project. Everything is there. Same settings that was working in the first project in here. So you can compile easily. Okay, no problems, no errors. Same stuff. Then you take, you see the changes here, and it changes that guy, and it should be good to go. Don't need to make file new and stuff. It will, it will create another project, of course, from scratch. Then you need to do, all the steps that we usually do, the driver lib stuff, and all this you don't need now. Just copy and paste. Okay, and of course it changes the name. Okay, guys. So let's delete it because I don't need it. So this should be easy. Okay, you have here the code on the screen. Just again, copy and paste this guy from your workspace and paste it in here. It changes the name to something like this. Okay, and I advise you to use my naming. Okay, so that we can refer, or when you discuss about some project, if we have the same names, I will know what exactly would be the problem in that. Okay, so guys, go forward and do that, and if you have a problem, just let me know. I will be with you. Okay.
Professor, I just had a
Yes.
question about the code because when I was working on the second lab assignment, is there like a certain
homework.
yeah, I mean the lab assignment too with the
Yeah.
RGB stuff, is there
Yeah.
another like, wait function we can do, or is this if statement like the only possible wait or delay we can do?
You can make a delay with timer,
Okay,
but we didn't take timers yet.
okay,
You
got
know?
you. Okay.
Wait, so Professor, what you mean by that is just add the time library. So like hashtag include time.h, or I think it was time.c, and then just
No,
add
I'm
the time delay.
yeah, there is something called timers. So in timers, you configure some board that you're gonna use timers in it. Okay, then you configure some registers to the exact time. So, and it has some, it's not that easy to explain, but you can set some delay using you can configure a timer, and whenever this timer times out, then you will toggle the lid. Okay, and redo it again. It's like a stopwatch, but it is recurrent. So for example, you set it to 5 seconds, then for each after each 5 seconds, then something will happen. They to reset again, and recount until 5 seconds and reset. We're gonna see it, don't worry. Okay.
Yeah, got it.
Okay, so Dominique, you finished, right?
Yeah, I did.
Okay, just wait for 1 minute
Okay.
because I need to. I'll just create assignment because I didn't do that. Just show me Dominique your screen. Okay. I wanna show I wanna see the code itself.
I'm sorry. How do I do that?
Share screen.
Uh,
Yeah, you did it. Okay, my friend. Okay. Let me give you the Dominique, right? Okay. If you have question,
Wait,
you just
Professor, I think that one's mine.
Who is this? This is Alan O?
Yeah,
Okay, I'm sorry.
the screen share is mine, Professor. Yeah,
Okay,
thank you.
okay.
Yeah.
If you have a question, Alan, before you go, just
Mhm.
wait.
Okay,
About
yeah, I'll stay a bit. Don't worry.
So do we just share our screen with you?
yeah, I'm sharing mine now.
Who is sharing
Okay.
now?
Me, Dominic. I think I should be sharing it now.
I'll stop sharing. All right.
Yeah. So guys, multiple users can share at the same time. So
Alright.
somebody
Am I
should tell
sharing
me.
it?
I don't know.
It
I
says
think Dominic.
I'm seeing
Yeah.
the professor's screen. So I wonder if we can.
Yeah.
Just,
This is Dominic.
Just
Okay,
comment
Dominic.
your name.
Okay.
Just comment
Yeah.
your
But yeah. But your name as a comment. Yeah, that's very good. Thank you. Okay, Mr. Dominic.
Okay.
If you have question, just stay. I can make a break room with you. If you don't have, you can just leave. Okay. Thank you.
Can I? Oh, is someone sharing right now?
I'm sharing right now.
Clark. Clark.
Yeah.
This is workable, right?
Yes, it is.
Good. Thank you. Clark, right?
Yeah.
Okay, Clark.
You want to see the robot blinking, or is that not necessary?
That's fine. That's fine.
Sharing my screen, I believe.
Who is this now?
Christian.
Yeah, I wrote my name right there.
Saul.
I guess I'll just share my
Please, guys, wait for 5 minutes because I wanna comment about the homework because many of you has asked about it. So please wait for 15 minutes. I will just give some guidance. Who else? Chris?
Yeah, I'm currently sharing mine.
All right, you want me to stop sharing mine now?
Yeah. Whenever you finish, just stop sharing, please.
Are you talking about Christian or Chris Bernardo?
So now, Chris, I'm done with you. You just
All right, Bernardo's done. Okay, cool.
Yeah. It's working, right?
Yeah. You want me to show you my
No, that's
robot?
fine. That's
Okay.
fine. That's fine. Who else now?
Professor, we're just copying the code you have on there, right?
Yeah.
Okay.
Professor, I'm sharing my screen right now.
Who is me?
Christopher Villarreal.
Okay. Working, Christopher, right?
Yeah.
Is it working?
Yeah.
Okay.
Run it and stuff.
Thank you very much.
Hey, Professor, I have mine. I'm sharing too, whenever you got a sec.
Please, stop sharing for who is this is you, Genesis, now?
Yeah, this is me.
Can you write your name? I don't know because this is the same screen as if.
Oh, let me go do that.
Okay. And it's working, right?
Yes, sir.
Okay.
All right, thanks, Professor.
Mr. Mustafa.
Yes, Johnny. Yeah.
Oh, can I share my screen?
Yes. It's working, right?
Yes, I can show video.
No, that's fine. Johnny Polders. Okay.
I got mine to work.
Gustavo?
Yes. You want me to screen share?
Oh, share your screen, yeah. Okay. Okay.
All right. Thank you, Professor.
Okay.
I'm sharing mine, Professor.
Jose, right?
Yeah. Well, I'm also sharing mine.
The screens that I'm seeing right now is just write your name, please, as a comment to avoid any confusion. Okay. Okay.
So is it mine that you're looking at, or is it someone else's?
Yes. It was you. Stop sharing now.
Okay. Thank you.
Working, Mark?
Yeah.
Okay. Thank you. Ivan Hunter. Ivan. We still have Christian Gonzalez. I don't know if he's with us or not.
Oh, I thought I already shared my. Here, I'll share it again.
Share it again, please. Yeah.
Okay, yeah, here you go. And, all right, can you see it?
Yes. Okay, thank you.
Yeah, no problem.
Ivan Hunter, you have a problem? Okay. He's not responding. That's fine.
Are you going to be going over the RRT homework or the next lab homework?
Yeah. So basically for the RRT or even the PRM, okay. Yes, Dominique.
Oh, sorry. I meant I unmuted myself. I was gonna say, are you gonna about the midterm? You said you were gonna tell us something by Monday.
Yes. So basically, the midterm would be next Monday. Okay. I will announce this today. So it will be next Monday, October 26th. Okay. Same time of the lab. Okay. It will be 1 hour, and it will be one-dimensional. What's it called? I forgot. Artificial potential field. Okay. So you remember, guys, we studied artificial potential field in two, environments, 2D environment and 1D environment. When the robot is moving along the line, x-axis, for example. Okay. So it will be on artificial potential field, one-dimensional. It will be, you will have the code. The code is simple. I know that. So you will just fill in some parts that is missed, and I will point to you. Fill in here, please. What else? Yeah, what I didn't decide yet whether to make it just complete or make it multiple choice to make it easier for you. But I think it's already easier. So I just decided what should be what you should exactly study, and even this is also I also decided which environment, which is 1D environment, which is very simple. So I think this is enough for you. So you will just complete, you know, some parts in the code that is not that it's missing. Okay. So I think it will be easy, very easy for you. Just study well the code that I gave you. Okay, the one-dimensional artificial potential field problem. Okay, in which a robot is moving along x-axis. Okay, in the examples I will give you, it may be moving along y-axis. You know, it's the same. It's one-dimensional, or even x-axis, the same as the ones that you have. Okay, so please study this code very well. The exam is closed book. Okay, so please don't open the code, the artificial potential field in front of you. Okay, whenever the exam starts, please don't open anything related to artificial potential field. Okay, you have the exam, you will study it before and you know it, so you just complete the code that I will send it to you. Okay, it may be over Canvas, and it may be I sent you only the code and you just reply it to me as a homework, something like this. But of course, the reply should be before the deadline. With the deadline, of course, it will be just 1 hour from the start. Okay, that's clear?
Yes.
Okay, so regarding the homework, the MATLAB code, yeah, let me open MATLAB. It's not open, come on. Let me open it very quick. Okay, so since I didn't send any files that for the functions, so for the BRN code, you will just, you know, make a function, create a function, okay, called the via obstacle. So this function receives some inputs and, you know, should you know, return some value, either true or false. So this is a BRM code. Let's see, where is this line of via obstacle? Yeah, this one in here. So what you're gonna do exactly, you will do something like this. So you create a file which will contain the function code, okay? And in MATLAB, there is a kind of, you know, this function should return something, okay? So in that case, it's returning true or false. So you must have a variable. This variable will take you know, the return of this function. Okay. So here, besides the function keyword, you put any name for this variable. This will take true or false. So for example, let's call it Boolean variable. Okay. So now you created a file. This file has some keywords, okay, to define this is a MATLAB function. This is the function name, okay, and this file should have the same name of the function. This is a requirement for MATLAB, okay. So this file here should take file name via obstacle. So let's store it. Okay, via obstacle. Okay, and it should be stored in the same folder as the BRM code or RRT if you are doing it for the RRT. Okay. Okay. Now with this, still your code, of course, is not returning anything, so you will have some error. So you must give some value for the variable. So here this is our variable here, has a wrong name, some default value we can say. So via obstacle returns, if it returns true, then there is an obstacle between the two points. If it returns false, then there is no obstacle between the two nodes. So we will assume, for example, that there is obstacle. So you gave it true. It's of course a conservative assumption. Okay, you can do the opposite. By the way, you can initialize it to false based on the problem. Okay, then here you add some code. Yeah, that will change this variable. Okay, that may be changed, that may change, not will it change, that may change a Boolean variable. Okay, so we said that it's true. That means there is an obstacle. So you write here some code that will check the points along the line that we said between the 2 points, and if one of them is on, if all of them is not on belong to some obstacle, then you will change this to false. That means there is no obstacle between the 2 points that we are checking the area in between. Okay. Good. What else? Yeah, and of course, whenever you do this for the PRM, it will be the same for RRT or RRT star. Okay, and you will do something similar for the construct route. So the other function construct route. So let's do it here. Construct route. I don't remember exactly its name. So I think it was something like this. It returns the route. So it's a variable now is array. Okay. So you should initialize it something like this. So this is how we initialize an array. Of course, in MATLAB, you can initialize an array to nothing. None. There is nothing in there. Then step by step here, you add to the route. Okay. So at the end, route should be something like this. Goal ID, goal node ID, some point 1 ID, something like this, point 2 ID, until you reach start node ID. Okay. This is basically many questions I received lately about how we construct this function in MATLAB. Okay.
This is for RRT, right? This route?
Yes. Okay. I asked for RRT. Yeah, I asked for the route in RRT. Yeah. Let me check here. RRT. RRT. Yeah. Yes. But in RRT, I asked for both via obstacle, which you should already did with BRM, and also construct route. So the one you did for the via obstacle, the one you did for BRM, just use it here. It should be the same.
Oh wait, they should be the same?
Yes. Yes.
Okay.
Yeah. Okay. If you find yourself need something different, then you have some problem somewhere. Okay. Any other question, guys?
Hey, Professor.
Yeah, Jess.
Can you please go back to the route construction? I just want to see the comments you put down again.
Here. Of
Okay.
course, you should use here the inputs that in the. So let's go back. It's an RRT, right?
Mhm.
RRT. Yeah, you should put the same. Yeah, and the file name should also be changed. Okay, it should be construct route.
Okay.
Okay.
Thanks, Professor.
Thank you.
And then when whenever we're returning what's inside route, we should use those like 3 parameters inside, right?
What?
The map, nodes, and the tree connection.
Yes, you should use them. Yeah.
Okay. Thanks, Professor.
I'm not sure. You should use the map to check because the map will tell you if there is an obstacle or not at some point. Nodes, I'm not sure why we should use it, but sometimes I put some redundant variables that I may use in the future. But if we must or should or redundant, you can or cannot, I will answer later. I can send the email for this. Okay, because I need to check the code itself. But basically, these are, I can say, more than enough, or enough at least, to construct the route between the goal and the start. Okay.
Thank you.
Any other question, guys?
Professor, when you were talking about the midterm on Monday, I actually had to step out for a little bit, and then I only heard a little bit of it. So basically, it's on Monday and it's on 1D.
Monday, next Monday, 26, October
During
26.
lab.
Yeah, during lab, first 1 hour of it. It's 1D artificial potential field.
Okay.
Studied the code that I sent you. Studied very well because it's a closed book. It's
Okay.
not an open book. So please don't open the. I trust you all. If you do, I will not detect you. But it's up to you. But of course, it's a closed book. It will be dishonest, of course. So it's a closed book. Studies the code very well. Okay, it's one dimension. It's very easy. I explained it very, 2 times. What else? Yeah, what I didn't decide yet if it will be on canvas. So you will have the line of code and put some. Or I sent you a file which has some missing parts and you fill and bring it back as just as an assignment, but just 1 hour assignment.
Okay. All right. Awesome. And I also heard something a little bit. Are you gonna send an announcement or something on what
Yeah,
we
of
should
course,
specifically?
today.
Okay.
Yeah, today. Yeah, about that because I didn't do that. So I will, list down what I just mentioned to you in an announcement and send it to you.
Awesome. Thanks, Professor.
Okay. Okay, guys. Any other questions? Okay.
Professor,
So yes.
we get is it an hour that we get for the
Yeah, 1
midterm? Is
hour.
it the
Yes.
entire lab time?
No, 1 hour. Then we'll continue the lab.
Okay.
Okay. If you study the code very well, 1 hour will be more than enough. Okay.
Mr. Mustafa,
Mhm.
do you think we can practice a little bit with like the hexadecimals and stuff, but with the port 2? Or will that be our homework or something?
The homework, that's a very good point. So the homework will be, because I forgot to tell you about that. So the homework will be something similar to what we have done last time. So, what we did last time, we take lead one, and the homework was lead 2. Okay. So now the homework will be lead 2 but with bitwise operation.
Okay.
If I see any part with something like this, I mean, you change the bit and the other bit as well, then you will lose some point.
Right.
Some point. Okay.
For that
I
part,
will send it.
does it have to be hexadecimal, Professor? As well for.
Believe me, if you use hexadecimal, that will be easier for you.
Okay.
Because for some, if just train yourself to do that. Because for this is an easy question. Okay, an easy program or easy application. But for some other application, you may need to change, bit 3 and bit 7 and bit whatever. Okay, so the number will be, very, very difficult to relate it to some binary number. So you know which bit is 0 and which bit is 1. But if you relate it to hexadecimal, you can easily visualize which bit is 0 and which bit is 1.
Okay, and we don't have to use the XOR because I understand that part. It's just that it's not necessary to use the XOR for the second lab, right?
That's fine. Yeah. For second lab, we don't have to use XOR. Yeah.
Okay,
No.
cool.
We don't have. That's right.
All right, got you. Cool.
Professor, for the next lab you're gonna give, you want it in the setting and unsetting into the safe code like coding convention, where we use and or to set and unset bits?
Yes, safe coding or bitwise operations. That's right. Yeah.
Okay.
Well, thank you for the term. Yeah, this is called safe coding. Yeah, that's right. Yeah. Okay. Any other question, guys? Okay. See you next week. I'm sorry. See you tomorrow. Bye-bye.
Professor?
Yes?
I'm sorry, it's late, but I have a question. It's about something else.
That's fine.
It's it's about the DFS code done in MATLAB, actually, the one that we turned in a long time ago. I'm having a problem with it because I turned it in and it worked for all the examples except for one, and you emailed me about it, but the problem at that is it checks its neighbors and it gets its neighbor on the left and this neighbor on top, but the distances between them and the start codes are the same, so it goes up by default, and that's why I'm not getting the shortest route. How would I fix it? Because I've been working on it. I have no idea how to do that. Like when two nodes are equal distance apart from the start node, it's gonna go up by default. So I don't know how to fix that. I don't know if you understood what I meant all too much.
Yeah. Okay. So, look, how to fix a code is actually the programmer problem. Okay. So basically, I think the idea that you are using is not correct. I mean, you have some idea, and you believe that this idea, if we apply it, if you code it, you will get the shortest route. Okay.
Well, it gives me the shortest route on every other problem except the one that wasn't on the code you sent us. You used a different maps, and at one of the maps where I think you had the goal node at 1010, it starts getting the shortest route, but at one point, you know how for DFS we check all its neighbors and we compare its distance to the star, and the one with the shortest distance get added to the route. At one point, the node on the left and the one right above have an equal distance to the start. And how do I know,
okay, I understand now. Let me remember how to fix this problem exactly. Yeah, two neighbors and both have the same distance to the start, right?
Yeah, and then it goes up by default, and then that's when my route gets messed up.
Let me remember what exactly we should do here. Can you show me your code?
Yes. Let me
share your screen. Yeah.
Let me open it up and then I'll share my screen.
I have a solution for it, but you should show me. Yeah, show your screen.
Okay, so okay, it should be the right screen right there. So I forgot which one. I need to check my emails because you emailed me about it saying I still have a bug on one of them. Just so I can get the right example.
Yeah. Yeah, go to the emails and bring it back.
So let's just change this one right here.
Or show me the example in which this this problem happens.
Yeah,
in which you have two nodes.
That's what I'm trying to change this. I'm trying to change example 1 to match the one I'm talking about.
Okay.
10. Okay, I think it's this. So if can you see the figure?
Yeah, yeah.
Okay. Yeah, I think when it gets to this node, what is that? It's like 96. The distance between the one on the left and the one above is the same. And that's, like I said, by default, it goes up. And that's why I get this buggy route.
Yeah. I understand. There is a solution for it, but I'm trying to remember right now. Can you go to this part in which you are checking the neighbors, the distance to start of the neighbors?
Let's see. Right here for checking distances.
Yeah. So this problem, I think, happens with Genesis. You know Genesis? Yeah, you know him?
No, I don't know him personally, but I've seen him in class.
I understand. Yeah.
I can try getting a hold of him and see if he can help me out with this, but
no, I just can't remember what was the solution. That's That's
Yeah, because it works for all the other examples on my main except for this one right here. And I've been trying to figure this out.
I even
can't think
forget
of a
my
way.
I even forget my code just gone because my hard drive just break away. So even my code is I can't go over it again. But there should be a solution for that. Give me just 2 minutes, more
Okay.
2 minutes. I'll try, to find a solution for it. So, just for now, okay, until we figure out this. So all other maps are good, right?
Yeah. I can show you all the other ones, and it works.
No, I trust you. That's fine. So what you're gonna do now? Just copy and paste. So can you run the code? Run the code. Yeah. Go to edit in the figure. Edit. Yeah. Copy figure. Just go down. Yeah. Copy figure. Now go to Outlook or whatever. Outlook. You know Outlook?
Yeah.
Yeah.
I already have it open right here.
Good. Yeah. So forward this to Genesis.
Forward this to Genesis.
Yeah.
Okay then.
And make me a CC.
Okay.
And tell him that the professor told me that you get this problem before, and we figured out a solution with him when he asked me about it. So then he gonna share. He can share now the solution with you. That's fine. Okay.
Okay.
But I will give you. Let me see.
Yeah, because I didn't get points the first time. That's why I submitted this a while ago, and then you saw the email you sent me, and it's just since then I haven't been able to figure it out.
Who is with me? I forgot. Dominic.
Dominic.
Okay. I'm gonna give you 7, my friend, out of 10. Okay, but please try to reach out to. I'm sorry, 6.
Okay,
6,
that's fine.
just like the other guys. But if you reach out, it will be 8. If you could solve this.
Okay, yeah, I'm writing the email right now to Genesis.
Yeah, and put me a CC.
Mm-hmm.
And put me as a CC and mention that in the email. Okay. So he can help you out. Okay. Okay, you have any other question?
No, that was it.
Okay. Thank you very much. I have to leave. I'm sorry.
It's fine.
Thank you very much. Bye-bye.